Hello, my name is Steven Floyo and I'll be presenting my final project for Module 3 and CS170. It is currently April 30, 2023, and this project was done by me and Mr. Kurt Kabungkal around 6 months ago for the same course. For the data gathering, we use the Kobe dataset that we got from Kaggle. Here it is. And now we will attempt to analyze this dataset. Okay, data gathering. We gathered Kobe dataset which we followed the fourth method in the data gathering methodology. And okay, so we have pandas, of course, seaborn to visualize, numpy for the operations, and the plots, matplotlib. And these things to help us create and evaluate the machine learning models. Okay, let's go. Check the dataset. We have okay, we have the first 10 inputs and see the number of data we have. We have around 30,000 shots. Data cleaning. After the data has been gathered, the next phase is data cleaning. Okay, in doing this, we attempted to find missing values, things that have null or zero, and we have them right here. And we separate them from the true shots and the null shots. Okay, now that we separated the null values, we now have 25,000 uh, 25,000 values, as well as these other unique values and frequent values. Okay, now that we have cleansed our data, we now go to EDA. This phase refers to the critical process of performing initial investigations, discover patterns, and spot anomalies. In order to start this, we will create a hypothesis of thinking of problems that we can make from this data set. For example, is determining if Kobe played better during home or away games, or or checking shot Kobe's shooting percentages in different NBA seasons. And I think we made other problems below. Okay, with the given dataset problems, some data science questions could be formed, such as what are some possible machine learning models that could be used to solve the given problem statement, and later which error metrics would be used to compare different machine learning models, and which would be the most efficient model from the models that we will be creating later to answer the problems. Okay, null shots. Okay, so basically, when we remove the null shots, the number of shots that was left was the shots attempted by Kobe. We will be using this as our training dataset. Here it is. With the true shots, we determined which are the ones that went in and didn't went in. With this, we discovered that Kobe missed 55% of his shots and synced in 44%. Wow, that's amazing. Okay, and now we try to look at his shooting percentage on different NBA teams. Let's see. Oops, he has the highest in New York Knicks. Okay, next is Kobe's shooting percentage on different parts of the court. This can be represented using this. For example, the center, the left side center, the right center. Here's the center, the left side center, right side center. Um, so far in my previous data science skills, I couldn't visualize this in here, so I just used bar plots using Seaboard. Okay. Kobe's shooting percentage in each NBA season. Now we check his yearly shooting percentage, to which we can see peaks, to which we can tell that he performed significantly well in certain seasons. 2012, yes. And his first few seasons, he definitely did. Okay. Determining if whether Kobe played better in home or away games. Aha. As we can see here, it was it was actually pretty convenient that Kobe only played with one team, LA Lakers, in his whole career. So to separate that, we could just determine the teams that were not from the LA Lakers as away games. Okay. Assessing every action type percentage of success and occurrence. In getting that, we can see that Kobe's most attempted shot is a normal jump shot, to which he attempted 15,000 out of his 25,000 shots. So we can see that the jump shot made most of his attempts significantly, even compared to his second, the others. That's pretty amazing that as a basketball player you can learn from just analyzing Kobe's data. Amazing. Okay, now that we explored the data, we created a number of hypotheses to which we can use to analyze. We now create the model. So for the libraries that we'll be using here are the scikit-learn and others. And as we see below, we created 3 models for this. And these are the logistic regression, decision tree, and random forest modeling. Create data set. Okay, here's our model 1, here's our model 2, and here's our model 3. And the voting classifier, we will use this to get the 3 models, compare them with each other, and determine their accuracy, to which we can compare them with each other and get the highest percentage. Yeah, we created our models. Okay, now we get to the model evaluation, and we will use different evaluation metrics to understand a machine learning model's performance as well as its strengths and weaknesses. Okay, so we actually use scores, cross-validation scores, and test set score. Okay, in evaluating our data, so we have our 3 models. The highest accuracy model had this value of 68%. Looking back, it is the logistic regression. Okay, it was detected by the voting classifier as the highest model. So in conclusion, we assess Kobe's dataset, the accuracy of our model, and we have come up with a 68% accurate model. Okay, that ends my project for this course. Thank you.